In this video, I'm going to explain to you how to configure GRE tunnel using a real Cisco demo lab. I'm going to go to all these routers R1, R2, R3, and R4. I already issued the command show IP in brief so I can see what are the interfaces attached to these routers, and I issued the command show IP route. So if you look at R1, R1 knows about 10.0.0.0/8 and 172.16.0.0/16, and same here with R4. And you can see R4 and R1 only has static, connected, and local route. But if you go to R2, you can see it is doing EIGRP, dmin EIGRP, and it only knows about 10 network. Same here, R3 also. So if you want to route packet from R1 to R4 to 172.16.0.0/16 network, it is not going to work. So let me ping R4 interface IP, that is the 10 IP 10.10.3.2 from R1, ping 10.10.3.2. It will be successful. If you ping again, you will be getting 100% success. You lose the first ping because of ARP, and you have the same results here. Ping 10.10.1.1. You get 100% success, and you can do the same from here. R2, ping 10.10.3.2, that we are pinging R4 E0 interface from R2, because R2 know about 10 IP network, so it is successful. But it cannot ping anything in 172.16.0.0/16 network because R2, R3 doesn't know anything about it, so it will not route those packets. So what we have to do is we need to create a tunnel from R1 to R4 so we can route those packets through the tunnel using the 10 network. So let's do that configuration in R1. Conf T interface tunnel 0, and you need to have an IP address for the tunnel. IP address 172.16.99.1 255.255.255.0, and tunnel source IP is the local IP address 10.10.1.1, and we are going to use the remote R4 router E0 interface as the destination. IP for tunnel destination 10.10.3.2. Now you see the tunnel was up before when we created it. Now when we have all these IPs, source, destination, and tunnel IP, the tunnel became up. So let's do the same thing in R4. Conf T int tunnel 0, IP address 172.16.99.2 255.255.255.0. Tunnel source is the local IP 10.10.3.2. Tunnel destination 10.10.1.1. That's the remote IP. Now the tunnel is up. So let's look at the tunnel status. Show IP interface brief tunnel 0. You can see tunnel 0 is up, and we go to R4 and do the similar command. I'm going to use show interface. Instead of brief, I'm going to use tunnel 0. That is going to give you more details. That will tell you tunnel source IP, destination IP, encapsulation is tunnel, keep alive not set, and all kind of detail interface IP of the tunnel. So you get more detail if you do not use brief. So now let's ping the remote tunnel IP from R1, ping 172.16.99.2. It is successful. So now let's look at the routing table, show IP route, and now you can see tunnel interfaces in the routing table. And same here, show IP route, and you see the tunnel interface here. But if you go here to R2 and R3, show IP route, nothing changed. Show IP route, still the same. It doesn't know anything about 172.16 IP. So what we have done is the ping was successful through the GRE tunnel. The ICMP echo replies packets were encapsulated in the GRE tunnel, that is from R1 to R4. The IP packets from 172.16.99.1 destined for 172.16.99.2 was encapsulated with the second IP header from 10.10.11 to 10.10.32. So the packet was sent out of the R1 ETH interface and forwarded by R2 and R3 and reached R4 ETH0 interface. And then what R4 does is R4 then strips the outer IP header to reveal the encapsulated IP packets that is destined for 172.16.99.2. So R2 and R3 did not know that the other IP packets were embedded in the packet that they forwarded. So what we have done is, so we used 10.00.08 network to forward the packet 172.16.00/16, even though the transit routers that are R2 and R3 had no awareness of 172.16.00/16 network. So that is how the tunnel works. Hope this video is helpful for you. If you like this video, give me a thumbs up. Also consider subscribing to the channel and turn on the notification for my future video updates.